the wing of an airplane. It looks so simple, right? Just a smooth curved shape that magically lifts thousands of pounds into the sky. But if you could peel back the metal, you'd find it's not solid at all. It's a hollow, intricate, and incredibly strong piece of engineering. Inside, it looks more like a skeleton. And in this video, we're going to build a wing from the inside out using this 3D model. We'll look at each part and, more importantly, understand why it's designed that way. Everything starts with these, the spars. Think of them as the wing's spine. In a real plane, they are massive beams that run all the way from the root, where the wing joins the plane, out to the tip. You usually have a main spar or front spar near the leading edge and a rear spar. Their number one job, to handle bending. When the wing generates lift, it wants to bend upwards, just like this. The spars provide the massive strength needed to resist that bending and transfer all that lift force back to the fuselage. So, how are they designed? Engineers use powerful computer models to find the points of highest stress, usually right here at the wing root. That's why spars are thickest and strongest at the root and then taper or get thinner as they go out to the tip where there's less force. This saves an enormous amount of weight. They are often milled from a single massive billet of high-strength aluminum or, in modern jets, made of layered carbon fiber. Okay, we have a strong spine, but we don't have a wing shape. That's the job of the ribs. These are the pieces that actually create the famous airfoil shape. This precise curve is what splits the airflow, creating low pressure on top and high pressure on the bottom, generating lift. The ribs are like the ribs in your own body. They aren't the main strength, but they hold everything in the right shape. See these holes? They're called lightening holes. An engineer's job is to make things strong but also light. A solid rib would be too heavy. Engineers use another program called Finite Element Analysis, FEA, to figure out exactly where they can remove material without compromising strength. These holes are the result: maximum shape, minimum weight. Next, we add these small, thin beams called stringers or stiffeners. They run the length of the wing, connecting the ribs together. And at the back, we have the moving parts. Ailerons are on the outside of the wing and move in opposite directions to make the plane roll or bank into a turn. Flaps are closer to the body and extend out and down to create more lift and drag, allowing the plane to fly slower for takeoff and landing. So, when you look at an airplane wing, remember what's inside. It's not just a solid object. It's a hollow, precisely engineered marvel of spars for bending, ribs for shape, stringers for support, and a stressed skin to tie it all together. Thanks for watching. If you learned something, give this video a like and consider subscribing.